Number 22. A balloon filled with helium gas is tied by a light string to the floor of a car. The car is sealed so that the motion of the car does not cause from outside to affect the balloon. If the car is traveling with constant speed along a circular path, in what direction will the balloon on the string lean towards? Okay. First, notice that we have vector quantity. Despite we have constant speed, our direction of the car is constantly changing as it makes the circular motion. And what enables the circular motion is centripetal acceleration. And you need to be also familiar with inertia. Originally, we have air molecule that's distributed very uniformly, meaning it's all made of mostly out of oxygen and nitrogen gas, which makes like 96% of our, actually 99% of the air we breathe. And you also need to know the helium gas is much lighter than our oxygen and nitrogen gas. So what happens is that when the balloon is attached to the floor of the car, the balloon is actually floating above the floor. And that's what happens when you did not have the centripetal acceleration. Now what happens is that as you apply the centripetal acceleration of the car to keep the car to move in constant speed, our air density will create the gradient. In other words, let me make the best example out of it. So when you when you fill the water in a bucket, and say here's your arm, and then you are rotating it, our bucket here. Okay, if you make it fast enough, the water is gonna retain in the bucket, even though at the top it seems like the water is falling down. And it's the same concept here. So when you have this uniform air gas molecules, and then you are rotating it, what happens is just like the water in the bucket, you will not have this water skewed toward the side B of the bucket. So you will have a lot of air molecules or crunch there. However, our balloon is not gonna stay the same as it is. The reason is helium is much lighter, and then there will be a big gradient between the air molecules on the side B and also the air density of the helium. So it's going to try to float toward the side B where it's less dense and there's a less difference in the gradient. So we'll have the balloon that say it was in the center and it's pushed toward the side D here. Okay, it's just like when you have water. Okay, imagine the B side here, and then you have you have water here, and they say you have something like a helium balloon, and it's kind of easy to see that this helium balloon is gonna float up here, right? So it's the same concept. So eventually the helium balloon is gonna move toward the D side of our car, so answer must be D.